You are standing outside on a clear night. Above you, the stars. You have seen them your whole life. They appear fixed, eternal. The constellations your ancestors recognized are the same constellations you see now. Orion is where it has always been. The Big Dipper points the way it always points. There is something comforting about this. Ache, ache, ache. The universe, from your perspective, is stable. But look closer. That star you are looking at, that pinprick of light, is not where it appears to be. The light left its surface years ago, decades ago, sometimes centuries ago. You are seeing the past. You are seeing something that may no longer exist. And this fact, once you truly understand it, changes everything about how you see the night sky. The universe is not stable. The universe is dying. This is not metaphor. This is not pessimism. This is physics. The universe has a beginning. We know this from the evidence of the cosmic microwave background radiation, the leftover heat from the Big Bang, detected in 1965. But the universe also has an ending. Not in 5 billion years. Not in 50 billion years. We are talking about a timescale so vast that the entire history of the universe since the Big Bang, 13.8 billion years, is less than a rounding error. The universe will exist for trillions of years after the last star dies. Let that sit for a moment. The sun will burn for another 5 billion years. After it dies, Earth will be a frozen cinder, orbiting a white dwarf no larger than your planet, releasing only the fading heat of its collapse. But that white dwarf will continue to cool. It will glow for eons. It will fade. It will darken. And long after our star is nothing but a cold black sphere, other stars will still be burning somewhere in the universe, but not forever. The smallest stars, the red dwarfs that make up 3/4 of all the stars in the universe, can burn for a very long time. Astronomers have calculated that some of these stars could remain alight for 100 trillion years. 100 trillion. To understand what that means, you must know this. The entire age of the universe, from its beginning to right now, is only 0.01% of this number. The next star will burn for longer than the universe has existed so far. But even red dwarfs must eventually die. The law of thermodynamics is absolute. Entropy always increases. Energy is always spent. Stars are engines burning hydrogen into helium, converting mass into energy through nuclear fusion. This process cannot continue infinitely. The fuel will run out. When it does, the star's core will collapse. What happens next depends on the star's mass. Massive stars explode as supernovae. Medium stars like our sun shed their outer layers and collapse into white dwarfs. Small stars simply contract and cool, becoming black dwarfs, objects that no longer emit any visible light. No one has ever seen a black dwarf. This is because black dwarfs have not had time to form yet. The oldest stars in the observable universe are only about 13.2 billion years old. A star would need to burn for at least 50 billion years to cool completely into a black dwarf. We live too early in cosmic history. We will never see one, but they are coming. In the time it takes for all the stars we can see tonight to die and cool to black dwarfs, trillions of years will pass. And this is where the true story of the long dark begins. Because the death of the stars is not the end of the universe. It is just the beginning of a state the universe will remain in for unimaginably longer than it has existed so far. It is the age of the long dark. What lies ahead is beyond most human comprehension, but you must try to comprehend it. Because what happens in the long dark is the universe making a final choice. Whether anything that matters will endure, or whether everything will be forgotten. Let us step outside the timeline of human experience entirely. Let us imagine we are beings who live not for years, or even centuries, but for millions of years. We are still impossibly young, cosmically infant, but at least we can hold some of this story in our minds. The first part of the long dark is the age of the stars fading, one by one, and then in waves, the stars shut off. The universe dims. A star that burns for 100 billion years is a marvel, but it too will dim. As this happens, black holes grow. Black holes are the universe's recyclers. When a massive star collapses, it forms a black hole. These black holes feed on nearby material. Some become supermassive, anchoring the centers of galaxies. Others drift through space like cosmic sharks, occasionally devouring a star that wanders too close. But eventually, even the black holes must reckon with the second law of thermodynamics. Stephen Hawking discovered in 1974 that black holes are not truly black. They evaporate. They emit radiation, what we now call Hawking radiation, from their event horizons. This is a slow process. Thanks for watching, and see you see. An enormous black hole, one with the mass of 1 billion suns, would take longer to evaporate than the age of the universe so far. But a solar mass black hole, one formed from the collapse of a single star, would take about 10 to the power of 67 years to fully evaporate. That number is a 1 followed by 67 zeros. It is a quintillion times longer than the universe has existed so far. During this time, everything else, every star, every planet, every molecule of matter that has not fallen into a black hole continues its journey toward the cold. The universe is now so vast that the average distance between any two objects is almost incomprehensibly large. Galaxy clusters are separated from one another by distances so extreme that the light from one will never reach another. The universe is not just cold, it is lonely. But there is still matter. Protons, electrons, the particles that make up atoms. Do they last forever? This is where we reach the edge of what we know for certain. Physicists have been searching for evidence that protons decay, that they are not eternal, but have a finite lifetime. So far, no one has detected proton decay. But if it happens, if protons decay with a half-life of 10 to the power of 34 years, then even this vast age will eventually come to an end. What remains after protons decay? Electrons, photons, the lightest, most stable particles. These can interact with one another through gravity. At this point in the universe's history, trillions of times older than it is now, structures begin to form again. But structures of a type the universe has never seen. Electrons orbit the Hawking radiation emitted by black holes as they fade. These form atoms of a kind that cannot exist naturally anywhere in the universe today. They are cold. They last for almost forever. They drift through the dark. There is no light. There is no heat. There is only gravity, pulling everything together, ever so slowly, toward equilibrium. The final black holes evaporate. An enormous black hole with a mass of 1 trillion tons would take 10 to the power of 59 years to fully decay. This is almost incomprehensibly long, but it is finite. It will end. When it does, the last energy source in the universe is spent. What follows is a state that physicists call the dark era. There is no consensus yet on what exactly happens in the dark era, because we are talking about physics at scales and timescales that we may never be able to observe or test. But the most likely scenario, based on our current understanding of thermodynamics, is this. The universe continues to expand. It becomes increasingly empty. Electrons and positrons that interact through gravity form larger and larger structures, objects that are not quite atoms, not quite molecules, but cold, stable aggregates of matter drifting through an infinite, expanding void. The temperature of the universe approaches absolute zero. Not quite zero, absolute zero, is impossible according to quantum mechanics, but close enough that the difference becomes philosophical rather than physical. Any structure that forms will decay, eventually. Any energy that remains will be radiated away. The universe will approach a state of maximum entropy, a state physicists call heat death. And then, the universe becomes truly dark. No light, No heat, no chemical reactions, no motion, just matter, infinitely distributed across an infinitely large space, moving away from every other piece of matter at ever-increasing speeds. A few stranded electrons, a few stranded positrons, nothing that can interact, nothing that can change, nothing that can remember. This is not the end. The universe does not end. It simply becomes a state where nothing ever happens again. The timescale for this final state is difficult to even express. If you could somehow measure time in the dark era, would time even have meaning? Does time exist if nothing changes? These are not just philosophical questions, they are questions that physicists genuinely debate. But if we use our current understanding of physics, the dark era lasts forever. Not for an unimaginably long time, forever. Let us pause here. Let us really sit with what we have just described. The universe we see today, a universe filled with light, with structure, with the possibility of consciousness and meaning, is a temporary condition. It is a brief exception in the eternal rule of cold and dark. Stars are not eternal. Galaxies are not eternal. The very particles that make up the atoms in your body are not eternal. Everything we see, everything we know, everything that has ever existed or will exist, is a brief flicker in a cosmos that will be dark for longer than the light has burned. And we are alive right now. Right now, during the age of the stars. There is a word that gets used too often in discussions of this subject: bleak. People hear about the heat death of the universe, and they call it bleak. They say it is depressing. They say it makes life meaningless. But perhaps they have understood it wrong. Let us reconsider what we have learned. The universe has a lifespan. This is not unusual. Most things have lifespans. A star has a lifespan. A galaxy has a lifespan. A human has a lifespan. The fact that the universe also has a lifespan simply means it is part of the natural order. It is not depressing. It is just true. And there is something else we should acknowledge. The universe is dead. We are not worried about it. We do not mourn the stars that died before the Earth existed. We do not grieve for the civilizations that may have existed and vanished on planets around distant stars. These things are simply aspects of a universe that is vast, cold, and indifferent to human emotion. But we are not the universe. We are something within it. Consider what has happened in the age of the stars. In this brief, exceptional period, between the time the first stars ignited and the time the last stars die, something remarkable becomes possible. Life becomes possible. Consciousness becomes possible. Meaning becomes possible. You are a pattern of atoms that is complex enough to experience the universe. You can look up at the night sky and comprehend that those distant points of light are suns. You can understand that you are made of the same elements that exploded inside dying stars. You can know that you are, literally, made of star stuff. This is not a common thing in the universe. The long dark will know no such thing. There will be no eyes to look at the sky. There will be no minds to contemplate what the universe is or why it exists. The particles that drift in the final darkness will not know they are drifting. They will not know they are cold. They will not know anything. But right now, during the age of the stars, the universe knows itself. This is the privilege of living when and where we do. We are alive during one of the most remarkable periods in the universe's history. Not for much longer, in cosmic terms. The sun has perhaps 11 billion years left before it swells and engulfs the Earth. 11 billion years is incomprehensibly longer than any human civilization has existed. But it is a breath compared to the eons ahead. And it is a breath compared to the ages that have already passed. We are not at the beginning of the universe's story. The universe began 13.8 billion years ago. We are not in the middle. We are in the very early chapter. We are like readers who open a book on page 7 and assume we are halfway through, when in fact we are holding a 1,000-page epic and we have barely begun. This changes what it means to be alive right now. The physicist and cosmologist Sean Carroll once said something that captures this. Entropy is the reason we remember the past, but not the future. It is the reason eggs break when you drop them, but shattered eggs do not spontaneously reassemble. It is the reason there is a difference between the past and the future at all. This is true. And because entropy always increases, because the universe always moves toward greater disorder, every moment that we are alive, that we can experience meaning, structure, memory, and choice is a moment that defies the ultimate trajectory of the universe. Life is not a cancer on an indifferent cosmos. Life is a brief, intense rebellion against the eternal tendency toward disorder. And consciousness, your consciousness, right now, reading these words is the universe rebelling against itself. This does not make the long dark less real. The cold is still coming. The darkness is still inevitable. Nothing we do will prevent the heat death of the universe. But knowing this, truly knowing it, should not hollow out your sense of meaning. It should intensify it. The universe will be dark, but it will be dark for trillions of years. Not now. Not soon. Now. The stars still burn. There is still light. There is still time. There is still the possibility that life can find its way to other worlds, that consciousness can persist, that meaning can endure for far longer than Earth itself will exist. And even if, eventually, all of that fades, even if, eventually, consciousness fades from the universe entirely, and the long dark takes hold, and the universe cools to absolute silence, there will have been a time when it was not like that. There will have been a time when the universe contained light and thought and love and meaning. There will have been now. We are alive during the age of the stars. We are made of the ashes of dead stars. We are conscious, which means the universe is conscious. We are the meaning the universe has made for itself. The long dark is not coming soon. Let the stars burn while they still can. Let the light persist. Let the consciousness that arose in the universe's brief, bright age continue to search, to wonder, to find meaning in the dark. Everything ends. The universe will be cold. The universe will be silent. But that silence is still trillions of years away. Look up at the stars tonight. You are looking at the brief, brilliant age of the universe. You are looking at home.